Hey there, welcome back to 8-bit 32-bit. This is the concluding part of the Putnam PE 6502, which I have now got working, and I'll be showing you a couple of cool things that help me get it working, along with a little example of what you can do with another device called an oscilloscope. So here's the boot screen, and apparently the @ symbol is not the symbol you want. It should have a backslash, which is what Jason Putnam told me, the guy that designed and built this kit. So what you can do is you can hit the reset button down here, and hopefully that has now given us our slash, and my keyboard is now working, which is brilliant. So I've got the options of AppleSoft Basic, Integer Basic. I can go into Assembler or straight into a debugger. So let's go for 8000R, and I am in Basic. So I can do Yoldy Woldy Classic, print, hello, 20, go to 10, and now if I run it, let's just zoom out a bit. Yay! We've got our basic program running, and everything is okay. So this side of the board on the right hand side has the propeller, and the propeller is what is doing all of the video. It's got 8 cores, they're called cogs, and those are 32-bit, so it's actually superly powerful, more powerful than everything put together on the rest of the board. Then we've got a VIA, which is dealing with the inputs and outputs, and we've got a Max 232, which is dealing with serial, although I'm not using the serial. So this side of the board is working, and we know that. Jason said basically if we've got a signal and we're getting a prompt, that rebooting prompt and this menu comes from the propeller. So the right hand side of the board was working, and we weren't sure what was going on the left hand side of the board. Now at the time I only had a voltmeter, so I could tell that there was voltage going across most of, or in fact all of the chips. So after a few email communications with Jason, he gave me a few ideas to try. Resolder the headers, which are on the left hand side here, and he said he's seen quite a few bugs with those before. I really didn't think that that side of the board was important at all, and I'd completely overlooked it, so I resoldered all of the headers there, and I also took out all the chips and I reinserted them, making sure there were no bent pins and nothing else was going on that was weird. I still had issues, and basically I think what has happened is this crystal in a can has been causing a little bit of wobbles, and it hasn't been working properly. Now that basically drives the entire left hand side of the board, and that is the crystal 1 megahertz one, so everything's happening a million times a second. It's driving the 555 chip there, which is also driving then the 6502 processor, the RAM, the ROM, and then you've got all the logic. On the right hand side there is a separate crystal running at 5 megahertz, and that is driving the propeller on the other side of the board, which is actually running at 3.3 volts. So left side running at 5, right side running at 3.3. After resoldering everything, giving everything a little bit of a firm tap, I eventually got my menus up and running. In the meantime, I did buy an oscilloscope, a little handheld one, for about £20, and I'm just going to show you how that can help to troubleshoot these sorts of issues, knowing what is working and what isn't working. I will show you a couple of bits on the board. Okay, so what I've done is I've taken a couple of header wires, took them actually from my Arduino kit, and I've got one on the ground, which is the purple at the bottom here, bottom right, and I've put one on the address bus, and I've got one on the data bus, which is the white one there. At the moment we're looking at the address bus, so what's happening is the 16 bits on the address bus are being turned on and off in sequence, and connecting that to this lovely little cheap oscilloscope, what we're seeing is that address bus going on, off, on, off, on, off, and that is in real time, which is great to see. And we know that basically as the computer sat there idle, it's just being turned on, off, on, off, on, off. On the screen I'm still in Basic, and I've still got my hello program. So if I type in run, and I come back to our oscilloscope. As I hit enter on the run command, and on the screen you'll see now the address bus is looking very different. It's going and fetching that data and coming back, but the data is coming down the data line. So what we can do is do exactly the same. Just do Control-C to stop this program running, and we'll switch over to the cable for the data bus. Okay, so we're connected up to the data bus, got the same program there running, and hopefully you can see at the moment the computer is idle, and this is the data bus, so yep, it is looking at the data bus. Things are changing slightly. I'm going to type run, and now we can see that that hello is basically being told from the address bus to be pulled from the data bus, which is held in RAM, and be brought back down, and then it'll be displayed on the screen. So that's got to go across the propeller. But although it's only the word hello, it's going to and from RAM, being read, going back to the processor, and then execution's being made, and it's going back out. So we can see that quite clearly. So if I Control-C that to stop it, resumes normal service of doing nothing, pretty much idle, just reading random data.